Okay. All righty. Now let's see if it works. Somebody stole one of the pens. That would be no. It's still not working. Nope. Well, keep on persevering. I don't know why that. Let's see. No, I can't. I'm going to erase that. Hold on. Whatever. I give up. All right. Slope. We all know that the slope is delta y over delta x. And y'all have been, and this is 2.1 and 2.2, delta y over delta x. And of course that is also y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y'all know that, okay? That's also called the rate of change. Slope is also called the rate of change. You need to write that down. Now there's a difference between the rate of change with algebra and the rate of change with calculus. Rate of change. Now in business, this is a big deal. The reason it's a big deal is because you're able to tell whether you're making profit, whether you're making revenue, what the marginal profit is, and all that, or marginal revenue, all that stuff, okay? And that's why rate of change is so important. But they call it rate of change instead of slope. I don't know why. Another percentage difference, percentage, and this is real basic, difference, percentage difference, new minus old over old. If you want to see if something is an increase or a decrease, you take the new measurement minus the old measurement, put it over the old, and multiply by 100. That's your percentage increase or decrease. So you might want to put percentage increase or decrease outside of it. Again, that's pretty basic. In 2.1, they're calling over an interval. And you'll start to see the difference quotient down at the bottom of your notes on page 77. You start to see that. There's one other rule that or one other formula you might need, and that's called the point slope equation. And you've seen this in algebra, point slope equation. This is kind of a little review. 2.1 and 2.2 is a little review over algebra as far as graphing. Point slope equation is y minus y sub 1 is equal to m times x minus x sub 1. So what I'm going to do is go over a short little review on how to use at least two of these, and that way you'll be able to do pretty much 1.1 and 1.2. And then we'll show you what that means as far as a curve and as far as a slope. We'll show you kind of a 30-minute review. Okay? So let's move over to the next page. And I'm going to draw it graphically again, because most of the time in business and management you see graphs. So I'm going to draw a graph and I'm going to draw a curve because most of the time you're going to see a curve, and there's a reason I'm doing this, so a curve. And there's our 2 points, and I'm going to draw a blue line through those 2 points because you can't do, this is a curve, but the slope algebraically is approximate. Oops, don't want that. Sorry. There. It's approximate. Why is it approximate? Because a straight line is not a curve. Okay? So when you're talking about slope with algebra, you're talking about a guesstimate. Now, let's say that this point is 2, 2. And let's say that this point is 5, 6. Now I just want you, as a review, to give me the slope of that line, and then I want you, or the rate of change, because we're going to start using rate of change with slope, so you'll know that that's what it is, and give me the equation for that blue line. Shouldn't take you more than 2 minutes. No stealing of electricity in class. Okay, just make sure you give it back. Well, half the class looks like it showed up this morning. $14 out of 19 is not too bad. At least I still have y'all coming. Too bad I'm going to have to fail all of you. M is equal to, well, which way do we read? Left to right. So this is x sub 1. This is y sub 1. This is x sub 2. This is y sub 2. Plug and chug. Well, when I plug and chug, I teach all my students to use big sets of parentheses. So 6 minus 2 over 5 minus 2. So our rate of change is equal to 6 minus 2 is 4, and 5 minus 2 is what? 3. So 4/3, which is 1 1/3, which is 1.33. So our rate of change is 1.33, or 4 over 3. That means for every 4 that we go up or down, we got to go 3 horizontally. Okay? So M is equal to, that's our rate of change. Now, use your point slope equation. Y minus parentheses equals M times X minus parentheses. And since 2 and 2 is smallest, I'm going to use that. So that's going to be a 2 here and 2 here. So y minus 2 is equal to 4/3 x minus 8 what? Thirds. This 2 comes over as 6/3. And that's going to give us y is equal to 4/3 x minus 2/3. Thank you. So now we know that our y-intercept is what? 2/3, negative 2/3. So we know that it's going to cross down here somewhere. Of course, mine's a little bit off on this point right here. If you look, it's a little bit off, so I brought it down a little bit. Let me fix that. If it'll fix it, it probably won't, but I'll try it anyway. There it is. There we go. A little bit better. All right, so that's a little bit of review over that. If you were given a figure like, let's say this would be, let's say this is profit. Then your profit here is 5. 5 is your new, because we read from left to right, so this would be your new. 5 minus 2 over 2, that would be your increase. So 5 minus 2 is 3. 3 over 2 is what? 1.5 times 100. 1, 2, that's 150% what? Increase. And that's how you use those three formulas. And that's basically what 1.1 and 1.2 is. Now, when I give you homework, I'm sorry, 2.1 and 2.2. When I give you homework, I'll try to pull from the 5 or 6 problems that I have to pull from on this book. But I'll also pull a bunch of these, not a bunch, but 2 or 3 of these, just so everybody can get that review. Okay? And like I said, I want to show you this for a reason. The difference in algebra and calculus, the calculus brings that line down to here like I showed you before. And I'm going to change this to a red line. I'm in a red, and it's going to give us this point right here. And then you take your red line and you draw it like that. But the good thing about calculus is it just don't give you the slope there. It gives you the slope what? Here, here. So after I take the derivative, I can find the rate of change at this point. I can find the rate of change at that point. I can find the rate of change at this point. Where with algebra, you have to what? You have to go back and you have to get this and use that 2.2. And let's say this is 4 and 5. Then now you got to plug in 4 minus 2 and then 5 minus 2 or whatever the case may be. 5 minus 2 over 4 minus 2. Here you got to do 3 and 3 or whatever the case may be. You have to calculate each one. Where with calculus, once you find the derivative, all you got to do is plug in x and it'll give you that slope at that point. So you don't have to calculate. And that's the difference between algebra and calculus, and that's the point you got to see kind of inspire you or motivate you to learn the calculus so you don't have to what? Go back to the shovel. Okay? Shovel meaning algebra. So, now, that takes us to 2.3. Now 2.3 is where you actually get into the derivative. So you might want to make somebody got to outline what sections do we cover in chapter 2? Do we cover all of them or what? Yeah, that's that sheet that I told you to bring to class with you every day. That none of y'all are doing except one of you. What the hell? 2.6. All the way through? Is there any chapter 3 in there or is that unit? Okay, so unit 2 is chapter 2. Okay, good. That's what I need to know. 2.3 is where your test is actually going to start. All right, you may get a couple of questions about slope and out of 2.1 and 2.2. So let's just go ahead and say 2.1 and 2.2 is probably going to be 20% of your test. All right, the rest of it's going to be derivatives. We good? All right, derivatives. Now, what is a derivative? Well, I showed you before, and I'll show you again. A derivative is being able to find the rate of change at any point on a line. And that means to turn the secant line into a tangent line. And we did that with the, what do you call it, the difference quotient. There's your line. Let's say that's cost. No, let's say it's profit. Okay, profit going up like this. For number of problems or number of widgets you sell, you get this much profit, whatever the cost may be, or whatever. Anyway, we got 2 points, and we'll call that point the first point and that point the second point. Well, with algebra, that gives us the approximate, which that does us no good because if you're Michelin or if you're some big company You don't want an approximate. You want to know exactly where. So we bring that line down, and when we do, we get this. And we get that right there, which turns into a magenta color, red and blue. And that gives us that line right there. Now, as I said before, once you move that line up, you don't have to recalculate. All you have to do is just plug in the x and calculate. So how do we get that? Well, we did that the other day with the difference quotient. And I'm just going to draw a line here. And that's x. I'm not going to do it as pretty as the other one was. And that's x plus h. And that's f of x. And this is f of x plus h. So if you actually wanted to put a coordinate on this point, it would be x plus h, comma, f of x plus h. And if you wanted to put one on this blue one, it would be f of x, comma, f of x. Now we've all said in the difference quotient section, as well as this section, that rate of change is equal to the slope, which is equal to m, which is equal to y sub 2, f of x plus h, minus what? F of x over, well, it's h, but it's x plus h minus x. And that gives us a difference quotient, which gives us our rate of change. Now, is that still approximate? Yes. It's still approximate until you add what? What do you have to add to the difference quotient to get instantaneous? Huh? The limit. Half of half of half of half. And that means this guy is moving closer and closer and closer and closer and closer to this guy, and the hairline between them, and that gives us a tangent line. And once you find that equation, you can find any point on that line. Doop, 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 doop. Many points as you want. So, but as we found out in the last section, this can be very what? Very long, especially with a cubic function. I don't think I gave you a cubic function. You're welcome. Okay? If I gave you a cubic function, then you'd have to take x squared, and you'd have to get a trinomial, and then you'd have to take whatever's out front, x minus 1, and then you'd have to distribute and get a 6-term polynomial and all that. I figured if you could do a trinomial, just x squared, you could handle that, so I didn't give you a cubic. If you want me to give you a cubic, I will, but anyway, we found out. Now, the derivative. This is the derivative as soon as you do limit as h approaches 0. When you do that, when you put this little guy right here in, the difference quotient that was in algebra turns into a derivative. The derivative is the rate of change at that point. Okay? So now we just reviewed over 2.1, 2.2, and now I'm going into the notation of the derivative, since y'all understand that this is the slope, and then you add the limit to it, you have the derivative. What are the notations for derivatives? Well, most of the time the first derivative, if I give you f of x is equal to, let's say something simple, x squared. If I want to know the derivative of that function, some people call it f prime of x. Now the prime is what you need to get used to seeing. It's a little apostrophe, I guess you'd call it. Apostrophe's up in there, right? Apostrophe, yep, comma, apostrophe. Looks like a little apostrophe. You can write it any way you want to, but just know what it is. That means derivative. Some people like to change this to y. You know, go back to the redneck days. Then it would be y what? Don't get discouraged and leave. I hate when you do that. Go splash some water on your face. All right, y prime is equal to x squared. Now, the one I don't like is dy dx. I don't like it because people get confused. Some people write dy dx. Oops, this is not x squared, sorry. That's a mistake. Dy dx. Now, those are the three most popular ways of writing the derivative. So you need to get used to that. Again, this is the prime, and this is yucky, but people use it, okay? This means that you're taking the derivative of the y term in respect to x, of the y equation or y expression in respect to x. Now, what if you have, instead of y, you have c? Well, then it'd be c prime, or dc over dx. Now, what if you had c is equal to, and I'm going to give you some problems, these daggum business problems. C is equal to 200. We're not going to do anything with it yet, so you can write it down. This is how you would write the derivative. Now, a lot of you are saying, well, golly, I know this. Well, you might know it, but somebody else might not, and this might be where they got confused in the last time they took it. So be quiet and shut up. 4 square root of x. There we go. Now, how can I rewrite c as a derivative? Well, that would be c prime. That would be the easiest way. But what if I wanted to write it the complicated way? Well, what is this term right here? X. That goes on the bottom, dx. So that would be dc, and if it's capital C, you put a capital C, over dx. So that's the way you would say, okay, teacher, I'm fixing to take the derivative of this guy. You either pick c prime or these two right here. Now, I'm going to tell you something we were talking about in previous classes. I had Dr. Gobati for when I dropped him, and he would use this, and I had no idea what that was. Had no idea what it was. And he would write that, and I would just be oblivious because he didn't go over the notation. He just assumed that everybody knew it, and I dropped it. Okay? But that's important to somebody if you don't know it. Okay? All right. Now, you can find the rules real easy. Go to Google. I'm not going to try to find it in this book because I probably don't even have it. Oh, yeah. And her problem yesterday, for those that came in like 15 minutes late, the problem that she had yesterday is when you're finding the, what is it, marginal, what was it?
The annual percentage yield.
I'm sorry.
The annual percentage.
The annual percentage yield for a continuous, you don't just drop the P and drop the N, you put 1 in for it. And that's the only, and I had to go, I looked it up and I couldn't find it in this book. So I went to one of the business teachers and asked her, and she said just put a 1. That's what you do. So if you want to find the annual percentage yield for a continuous, for N you put in 1, and for the P you put in 1. It'd be nice if the book told you that, wouldn't it? The book sucks. Anyway, Google. I don't want Bing, I want Google. Pull up basic derivative, if you can spell, rules, or you can pull up formulas, either one. It's the first time pulling it up, so I don't know what it's going to give me. I'm trying to find the easiest one because I do it. Okay, we got a snip because that ain't big enough for y'all. Because the people that sit at the back of the room, no offense to those, in all my classes, the ones that sit at the back of the room are the ones that can't see. And they always, I can't see, I can't see. Not this class, I'm talking about just my regular classes. I don't know who that is in here yet. And just save that, and then we'll pull it in. Let's see what we got. There you go. There's your, and the ones I want you to focus on right now, I don't know what that is. Hold on just a second, and I'll change this to this and change it to this, and just kind of, well, that's not working. Anyway, don't worry about this one because I don't know what that one is yet. Copy these 4 down. Now, I'm going to give you another way to write them. Can you see them? The first one says d over dx of u to the n power. It looks like n. I can't tell. Just use n. It don't know there's an n. Yeah, n. It's n. Is equal to nu n minus 1 du dx.
What is it raised to the a?
What?
Is it an a it's raised to?
N minus 1. It looks like an A, but it's an N. That's called your power rule. That is the basic rule. That's what we're going to learn today. We may move into the product rule and the quotient rule. But I'm going to rewrite the quotient rule and the power product rule. I'm going to rewrite that for you to where it's easy for you to understand. The product rule can be done first times the derivative of the second plus second times the derivative of the first. You can do it that way.
U something. Is that U?
This, you know what this says right here? This says the derivative of u to the n. Right here, the derivative. So what you need to do is highlight this and say the derivative, because this is what it's saying. Yes, ma'am.
For the power rule after the equal sign, what does that say? Is that alien? After the equal sign.
It says nu n to the 1 minus 1. This really sucks. I'm sorry. I would blow it up a little bit more, but it'd make it more distorted. I'm going to rewrite them because I'm going to explain each one. But this one right here, each one of these, this guy right here, highlight each one of those and just put the word, the derivative of, because that's what that's saying.
So for product rule, u to the what?
U to the n is your actual what you'll be given.
Product rule.
Oh, product. UV. In other words, two things together. Like 2x times,
But what's the little symbol, the exponent?
that's the prime, U prime. First times the derivative of the second plus the second times the derivative of the first. And what I usually give you, I give you S and F. I'll just rewrite it for you right now. First times the derivative of the second plus the second times the derivative of the first. That's how you take the derivative of two things that are multiplied together. And we'll get to that. This one, denominator times numerator prime minus numerator times denominator prime over denominator squared.
So that d over dx is the same thing as dy over dx.
This is all this is saying in these rules is the derivative of uv, the derivative of u over v, the derivative of u to a power, the derivative of a function. That's all it's saying. It just confuses people.
So fs prime plus sf.
This is first times the derivative of the second plus the second times the derivative of the first. That's the easiest way to remember it. Unless you want to remember u prime v plus u v prime.
Can you explain what you wrote for the quotient rule?
Denominator times numerator prime minus numerator times the denominator prime over denominator squared. It'd be a whole lot better if I didn't have to write with a mouse. And then this, we'll get to this. Don't even look at that yet. Okay, just write it down, but we'll get to it. This is what I'm more concerned with right now. Now, also, the derivative of a number is always what? 0. The derivative of a number. If somebody says, what's the derivative of 4? The derivative of 4 is 0, and I'll show you how that happens in just a second with the power rule. Y'all got the power rule written down? Power rule is all I'm concerned with right now. Okay, power rule. If I give you f of x, and I want you to draw it out, f of x is equal to x squared. All right, I want you, if you got graph paper, that'd be great. But if you don't have graph paper, at least use a straight edge and draw f of x squared. You know, just use -3 to +3, okay? Please. And draw your little graph. And I want you to number it. I want you to label the points because there's a reason I want you to do this. Let's go with 0, 0. 1, 1. 1, 1. 2, 2. 2, 2. 3, 9. 3, 9. Well, mine's a little bit off, but that's the point. All right. And that's supposed to be more of a curve, but you can just use your imagination. Now, if we take the derivative of this function, that would be f prime of x is equal to, and this is the way you do it. You bring the 2 out front and multiply by the coefficient. Well, what's the coefficient of x? 1. So 2 times 1. I'm going to take my handy dandy highlighter. I'm going to highlight that 2, and I'm going to highlight that 2 right there. Okay? And then you put your x down. And then that's still to the second power. And you always subtract 1 from the exponent. And that's the power rule. So, f of x, f prime of x is equal to 2 times 1 is 2. X, and what's 2 minus 1? To the first power, which f prime of x is equal to 2x. Now, what does that mean? Well, we're going to take our handy dandy highlighter. We're going to highlight it aqua. Mainly this part right here. And then we're going to take our handy dandy straight edge. And that means I'm going to just pick a point. We'll say this is 2 and 2. That's the rate of change at 2 and 2 is that blue line, which is this right here. So what is the slope of the, and this is how you use it. What is the slope? I'm going to write this as a text. What is the slope, parentheses, rate of change at A 2 B 4 no 3 or let's go with 1 2 2.5 2.5 or what's 2.5 5 halves at 5 halves and C at 3. Now, before you do this, let's go back here. Before you do this right here, stop. I want you to go over here, and I want you to pick 2 points and find the rate of change. Of course, the rate of change is called what? Slope. In other words, do it your algebraic way that you learned back in pre-algebra. Any 2 points you want. Now, since these are all positive, we'll throw. I tell you what. Let's throw a negative in there. Let's make C -3. So that way, anybody that picks a point on the left-hand side, you'll see how it works. So pick any 2 points and find the slope algebraically. You can just use my points. Use 3 and 9 and 2 and 4. See what you get. Nine minus 4 over 3 minus 2. I got 5 for one of my points, but that's right in here. That's from here to here. That's the rate of change. But if I take 2.5, which falls between 2 and 3, if I take 2.5 and I plug it in, what's 2.5 times 2? 5. I guess. All right. Now, this came out to be exact. Will it always? No. It depends on the curvature of your function. If the curve is really concave, then you're going to see a bigger difference between the 2 points versus your actual slope. All right. How about at this point? Well, that's 2. Slope at 2 is what? But we measured between these 2 points and it became what? 5. See there? Every point is going to be probably different because the curvature. And that's why it's so important to be able to do the derivative versus being able to do the algebra. How about at -3? Well, let's draw a line at -3, and we'll make it red since it's going to be negative. 1, 2, 3, and that line's going to look really. I thought I hit straight line. Did I not hit straight line? Okay. Well, that's not right. Let me move it. If it'll let me move it. All right, there's the tangent line right there at 3, -3. So we plug in -3 and we get what? -6. Wow, that's totally different. See, all you got to do is plug in your x and find the slope anywhere on the line versus plugging in 2 points into your slope formula and having to calculate it every single time. All right, let's do another one. Now, before I start with another one, let me show you this. What is, if I give you f of x is equal to 4. F of x is equal to 4, then that means 0. But how do you get 0? Well, in algebra, all terms have what? They have a coefficient, and they have a what? A variable. And when in doubt, always write it the way it needs to be written, and hopefully you can work it out. The variable on this one is what? X to the what? X to the 0 power. Now use your rule. What does the 0 do? Comes out. So that's going to be equal to 0 times 4 x to the 0 minus 1. And that's going to give us 0 times x to the negative 1. And somebody finish it. 0. Why? Because that 0 cancels everything out. And you get 0. So the derivative of any number by itself, or any number with x to the 0 power, because it's sitting there, is what? 0. I put that on tests sometimes and people miss it. So with that, let's go ahead and do this. F of x is equal to 4x to the third minus 2x squared plus 7x minus 2. And I want you to graph that on your calculator if you can. I mean, if you got your calculator with you. If you don't, just look on with somebody. I'm going to make it small right quick so I can pull up my handy dandy calculator. And pull it over here. Y is equal to, would be a saddle. No, I don't know if it'd be a saddle or not. 4x to the third minus 2x squared plus 7x minus 2. Phew. Zoom 0. Okay, it looks kind of like that. And f prime of x. Now, can you imagine plugging x plus h into all that? No, Hubert, that would be awful. Yeah, it would be. Thank you, class, for being interactive. Y'all suck. 3 times 4 is 12. And then x, 3 minus 1 is 2. Minus 4. What's 2 minus 1? 1. Plus 7. And what is 1 minus 1? X to the 0, which is negative 7. And this is x to the 0. 0 times 2, 0. So it goes out. So here is your rate of change at any point on this curve. Now, it's going to be a funny rate of change because what is this? It's a parabola. So if you actually put that in there, you're going to see, what did I just do? Oh, really? If it quit putting freaking pictures up. Okay, anyway. What was my problem now? Let me go back. Y is equal to, sorry, f of x is equal to
4x cubed
4x.
minus 2x squared plus 7x minus 2x.
Minus 2. And f prime of x.
12x squared minus 4x cubed plus 7.
Now, in business, you're not going to look at the graph that much. What they'll do is they'll say, well, what is my rate of change at, and this might be cost,
Yeah,
and they'll say,
take the derivative
what?
f of x on the second.
Sorry. There we go. Sorry about that. Don't want to mess anybody up. There's my prime. Basically, they'll say f prime of 200. And of course, you would do what with that 200? You'd plug it into this formula right there. Okay, and we're going to do that here in just a second. So with 2.3, if you look on page 87 of your notes, they're just showing you, and they're also showing you your difference quotient in relation to f prime of x. That's on page 91, so I'm covering that. And then 2.4 is where they actually get into the limits, and we're covering that right now. So let's do another one. Let's do f of x is equal to 2 square root of x. Quit. Just throw your pencil down. Make it pop, like I used to do. Radicals and calculus do not mix. Change it. Equals 2x to the 1/2 power. Now you have a what? You have an exponent that you can bring out front and subtract 1 from. So do it. God, they're still going through the difference quotient on page 95. 2.5 still there. Good gracious. We've already done all that. But I'll throw some on the homework just in case. Just kidding. All right, now you may need your calculator for this. Take half of 2. X and 1/2. Oh gosh, I don't know how to do 1/2 minus 1. That's a fraction. Well, that's 1/2 minus what? 2 halves. Which is 1x to the negative 1/2. Now, is that the way you're going to leave it? No. That's all over what? 1. So I'm going to take this guy because he sucks. He's got a negative exponent. I'm going to take him where? Downstairs. And that'll give me 1 over x to the 1/2, which is equal to 1 over the square root of x. We don't like that either, do we? Why? Radicals in the denominator, so square root of x over x by rationalizing the denominator. I'll take either answer, but I will tell you that you need to rationalize the denominator. But I'll take either answer. I don't know what the homework will take. Probably something crazy. So let's do a nerd. Then we're going to put it all together. f of x is equal to 3 times the cube root of x to the 4th power. No coughing in class. Y'all just can't get these rules down, can you? Beck, Bidenbaugh,
Here.
Bowers,
Here.
Branyan,
Here.
Bundrick,
Here.
Cromer, Dove,
Here.
Dunkley, Griggs,
Here.
Hildebrand,
Here.
yes, Knott, yeah, he texted me what will be here, Keebler,
Here.
Lilly,
Here.
Montero,
Here.
Seidner,
Here.
Sullivan,
Here.
Thomas, Walker,
Here.
and White.
Here.
All right, first thing you're gonna do is clean it up. It's yucky. Exponent over index. So that's going to be equal to 4/3 times 3 over 1 x to the 4/3 minus what? 3/3. That's going to give us, what happens to the 3's? And 4 over 1 is 4. X to the what? 1/3, or if directions dictate, 4 cube root of x. Now you're able to take the derivative of any term, because I've shown you a regular exponent, I've shown you x to the 0, which is a number, I've shown you 2 radicals. So you should be able to knock them all out. So let's try one. F of x is equal to 2x squared minus x plus 3. And I want you to graph it on your calculator so you can actually see the tangent line. So that means we got a parabola. Don't try to hide it. 2x squared. I know you're smoking them Marlboro Reds. Minus x plus 3. I just think they're nasty. I think all of them are nasty. And the reason that is because when I was in the Marine Corps, when I was in the Paris Island, hell, I had a drill instructor that he had horse teeth. You ever seen somebody that has horse teeth? They just got these big teeth. And he was from Long Island. His name was That was his name, Quiotis. And he had a red face, always had a red face. and he had those horse teeth, and he smoked 3 packs a day, and he drank 2 gallons of coffee every morning. So when he got in your face, I just about gagged, because that's one of my things I can't handle. And I really I just learned not to breathe whenever he got in my face. But you could actually feel his breath because it was so nasty. And ever since then, it just repulses me.
PTSD or something?
Huh? Yeah, it did. But anyway, that's why. All right, there's your function. And I'm not going to graph 4x minus 1 because it's going to put it right in the middle of the graph. But what you can do, 4x minus 1 is going to be a slanted 4 over 1, 1, 2, 3, 4, 1. It's going to look something like that. And you can put that anywhere on the line. So I'm just going to go ahead and graph it. And it's zoom. Okay. I got to wait for it to graph. Hold on. Now I done shut down my calculator. It's not working. There we go. There we go. All right, there's your graph. Now, if I wanted to put this line, take my handy-dandy line mover and put that, well, I can't do that either. God. Anyway, this sucks. I have to do transparency. There we go. And I put my line, let's say right here. And then I move it. There. And that is 1. Let's say 1 right there. Then we can take our formula, and 4 times 1 is 4 minus 1. So the slope of that line at 1 is what? 3 over 1. Now, if you was to take 0, or I don't know what the vertex is, we'd have to go ahead and take complete the square and find the vertex right quick. Because we're going to use the vertex in 1, 1 to find the slope and see what you come up with. And you see, that's why you need to know this stuff, because if you need to find the vertex, or you can switch over and complete the square and find the vertex. So 2x squared minus x plus blank is equal to -3 plus blank. Factor out of 2, so you're going to multiply that by 2. Factor out of 2 here, that's going to give you x squared minus 1/2 x plus blank is equal to this stuff, -3 plus 2 times blank. 1/2 divided by 2 is 1/4. 1/4 squared is 1/16.
Why are you multiplying by 2?
Because I factored it out right here. Whatever you factor out, you multiply by this blank. 1/16. And that's going to give you 2 times x plus minus 1/4 squared is equal to, okay, take that out as 8. 1/8, and this is 24/8, so -24/8 plus 1 is -23/8, right? So that's my vertex. I don't care about the x-intercepts because we see that it what? Doesn't cross the x-axis, so my vertex is what? 1/4, comma, 23/8. And 1, 1. Find the slope of that line. Use your calculator, because I know some of y'all's head's going to explode. All you got to do is change it to a common denominator, but anyway. One, which is 8/8. You could do it that way. 8/8 minus 23/8. No, that wouldn't be 1 and 1. I'm sorry. That would be 1. 4 times 1 is what? 1. And that'd be 3. 1 comma 3. I'm sorry. My bad. So that would be 24/8 minus 23/8 over 4/4 minus 1/4, which that will give us 1/8 divided by what, 3/4? Well, you divide by a fraction, you multiply by the what? Reciprocal. And that's going to give us a 1 there and a 2 here. So the slope is 1 what? What did we get at 1? What did we get as a slope at 1 when we did the slope a while ago? Well, at 1, 4 times 1 is what? 4 minus 1 is what? 3. So do you see a difference between 3 and 1/6? Yes, there's a difference. So depending on the curvature, you're talking about an approximate versus an exact. And anytime you take calculus, when you're finding the derivative, basically you're finding a point in time or a point in space, you're finding the tangent line. Now, in the application of engineering, some of y'all took engineering calculus, which you probably can take after this class because, you know, I'm showing you this stuff. Engineering calculus, you have to understand in engineering the particle in space. Well, this is the first part. If you find the particle in space, if you find the tangent line, then you can find the normal line. And the normal line is the acceleration. You know, acceleration of a particle in space. First, second derivative. So it starts to tie in, but you can't understand calculus unless you understand algebra. And that's the first thing. And that's why a lot of you have to brush up on your algebra to understand it. Now, that's that. Okay? So, any point. What about at -2? -2 would be right in here, a line going this way. -2 times 4 is -8 minus 1 is -7. So at -2, you got a slope of -7. Capiche? Now, what if you're given cost, and you need to write out cost because that's what big C usually means in business. Cost is equal to, let's just say 200 times 3x plus 4 square root of x. Okay, now this is just like, I want you to make a note here. This, we're not taking the derivative of because it's a multiplier. It can be pulled out, okay? Just like, you know, when you factor out something, you can distribute it if you want to and do it that way. You're still going to get the same thing. As long as those parentheses are there, you don't have to mess with this 200. Or you can do it the hard way and you can distribute it and do it, include it. So we're just going to leave it outside and not fool with it. You're going to take the derivative of this guy and this guy. If you was to, you would get 600x plus 800 square root of x, and then you could do the derivative of both like that. If you really like whips and chains, and that's, you know, that's punishment. I mean, I would stick with this. Just do the inside. And it should be pretty simple for you now. And I'm just curious, how many of you took this class before? Okay, question for y'all. How are we doing now versus last time?
So much better.
You speak English, so.
Well, okay. I'm talking about the concepts of chapter 1 and chapter 2. Is it a whole lot better? Good. If let me know if I'm missing anything, because you'll know if you're missing anything in this chapter, because this is the chapter that you actually start working with derivatives. So you'll be able to tell me if you don't understand something. All right. So that's going to be C prime or dc over dx. I'm not going to use that, but you can write either one of them. Is equal to 200. I'm going to do both of them, so you'll see that you're going to get the same answer. And that's going to be 3 plus, okay, what is this? That's 4x to the 1/2. And that's going to be 200, 3 plus 1/2 times 4x to the 1/2 minus 2/2. And that's going to be 200 times 3. Half of 4 is 2x. 1/2 be negative 1/2. Now, you can write that 4 or 5 different ways. I got it down to 200, 3 square root of x plus 2 over the square root of x. Now, I'm going to put 3 dots here. 3 dots in a vertical line means you do the work. Okay? And I had Dr. Harden at Clemson, and he just mumbled. You know how to do it. That's what 3 dots meant for him. You know how to do it. That meant you know how to do this. In fact, if you go into Martin Hall and you go to his old office, 116, they got a plaque. When he died, they put a plaque up on his office. I think it's still there. He was real nice. He was the And then I had Dr. Ruckel. And Dr. Ruckel played Tetris all the time. What? Harden. H-A-R-D-E-N. What?
What did he do?
Math teacher. At Clemson. Martin Hall. Down, I think it's it's down on the basement because he retired and they put all the professors in the basement. And then, anyway, he was, that's all he ever did was little man about this tall, white hair. He weighed about 100 pounds. 200, he was my advisor. All right, and I got Dr. Ruckel played Tetris all the time. And he'd knock on the door. He had his back to the door. So when you knocked on it, you scared the crap out of him. And he was a big old man, about 6'2", 6'3", weighed about 325 pounds, big guy. And he wore this belt buckle with a star in the middle of it. I mean, dress clothes with a belt buckle, like a Western belt buckle, and he played Tetris all the time. Anyway, I got 200 times 3 square root of x plus 2 over the square root of x. Now, there's several ways you can write this, but that's probably the best one that I come up with. But you can work with it, and if you come up with it, that's fine. That's just simplifying. Now, if you do it over here, what's the derivative of 600? X. 600 plus 800 x to the 1/2. And that's going to be 600 plus 400 x to the negative 1/2. Now, what's in common? 200, Hubert. Thank you, class. You see? And the reason I show this is one time I was teaching Calculus 1 and I factored out a number And they said, well, you're going to have to take the derivative of that number. No. With calculus, you can pull out a number. It's kind of like factoring out, and you don't have to mess with that number as long as it's in common. So, yes, ma'am.
Can you show us how you got to 3 square root of x plus 2?
Yeah, that'd be 3 over 1 plus 2 over what? The square root of what? X. Now what do you get? Well, to add fractions, you got to have a what? Common denominators. Common denominator is square root of x. So square root of x. Square root of x is my common denominator. How many times will 1 go into the square root of x? Square root of x times. Square root of x times 3 is 3 square root of x. How many times will square root of x go into square root of x? 1 time. 1 times 2 is 2. And that turns into this. All right, let's do a revenue. Kind of the same type problem. R, capital R means revenue. What's revenue? That's money coming what? Coming in. Doesn't mean you get to keep it. You know, like gym owners do. They get thousands of people in the gym and they take the money and they just use it as their own personal, and then they go bankrupt in 2 years. Anyway, 60, no interaction whatsoever out of this class. 30x. I'll just get Mohammed Gubadi to come in here and fix y'all up. He'll fix you up right quick. Be lobotomized. Y'all just don't like me. Is that what it is? Just don't like farm boys. Is that what it is? So leave the 60 alone, or you can include it if you want to. R is equal to 60. What's the derivative of 30x? 30 minus 5 halves x to the 5 halves minus 2 halves. And that's going to be R prime is equal to, or D capital R over dx, 60, 30 minus 5 halves x to the 3 halves. Okay, now remember, you can find a point on these lines and you can find what the revenue is. But when you take the derivative, you're finding out how much the revenue is changing at that point. Okay? So you can go from one point to the next and you can actually see how much is changing, versus if you did it algebra, you know, you'd have to take a point up here and a point up here, and it would be approximate versus what? Exact. Approximate versus exact. It's just like when you take the square root of 2. The square root of 2 is exact. The square root of 2, when you type it in your calculator, is approximate. Okay? That's the difference. Approximate versus exact. All right? Marginal profit is P. -0.2 x cubed plus 40x squared minus 132.1x minus 500. Now, if you was to punch in 4, then you would find the marginal profit at that point. But if you take the derivative, then you're finding where it's changing at any point on that line. And we're going to spend a little bit extra time in today, so don't expect to leave exact time. That's why I took the roll early. I want to make sure everybody's got these down because I'm going to give you a bunch of little ones for homework. Because you can actually learn to take the derivative in your head. Some of these simple ones like 2x squared. 2x squared is 4x. I've got to get you to that point if you're not there with the simple ones. Well, that's going to be negative 0.6 p prime is equal to negative 0.6 x squared plus 80x minus 132.1. And this is a prime example of a problem looking very intimidating, but it's not. You just do the math. All right, different one. And this is another revenue problem. Revenue formulas change. So revenue is equal to 3x times 800 plus 40x minus x squared. What's different about this one? I'm sorry, what? You have a variable in that common, so you might want to distribute this one because that variable, or you can take the derivative of it, which would be 3, and then leave it out there, but I wouldn't do that. I would distribute it. No. You just stand here. Oh, okay. Just don't matter. They're working on the problem. Yeah, circle.
So it's bar graph.
Oh, I do. Sure.
Bar graph, so it's 254.
Okay.
And then I put them all, I think those are right here.
Good. Oh.
Anyway. And then start compounding
Yeah,
if you
I
can.
like doing that.
You could start that, that would be good, and then, I've got it on the problems.
I do the water.
Yeah, you pick it on,
Yeah.
yeah, I do that, and then what I usually do is do that, and I do it different on that, and then I do it, that'll be like after you go through it, so you can save that for later on. And then I go through it continuously, show the difference.
And 206.
206. I sent you an email.
Yeah, I know, but I
Okay,
just,
with my roster, so print out that roll sheet, I can sign it, and then I need to see an email to me, because if I wait till Tuesday to put in there. Scan email that to you. Or that's tomorrow, 12th, but I told
well, I'll be sitting in there, probably, I'll just sit in there for, after I finish this class, I'll just go down there and sit.
Yeah.
Okay.
Do you have any questions?
Okay, thanks. Points. Point. Get off the bad list. I stay on the bad list here at Dry County.
All right. The following formula is for generating, we're doing several parts of this question, generating revenue from renting X number of apartments. That's what it is, okay? So if you want to find the rate of change at any point, that's going to be equal to 2,400 X plus 120 X squared minus 3X to the what? Cubed. And we'll write that down as R prime. Now, A, find the revenue of 10 apartments and 11 apartments. Find the difference in revenue at 10 and 11. That means you got to use this formula because they're just asking you to find the revenue. Find the revenue. Question, did I make a mistake?
We just distributed.
Yeah.
Oh, I'm sorry. I'm stupid. Okay, R prime is equal to 2,400, sorry, 2,400 plus 240X minus 9X squared. Is that better? So they just want you to find the revenue and compare that revenue. B, find the marginal revenue. Marginal revenue is another way of writing rate of change. Marginal revenue at X equal to 10. So you're going to use your derivative here. So when somebody gets the revenue for 10 hollered out, when somebody gets the revenue for 11 hollered out, and I'll tell you if it's right or not. What?
3,900 is 10.
I didn't get that.
I got 3,300.
I got 33,000 for 10.
For the first one.
For 10 is 33,000.
That's what I got.
For 11,
For
36.
11 is 36,927. I know.
And then 11, I got 36,927. Tell me what the difference is.
39.27.
Okay, that's basically the difference. 39.27. In other words, if you was to take the slope, you'd pretty much get 39.27. Something to that effect. Now, what's the marginal revenue at x is equal to 10? And I'm going to put x prime is equal to 10. In other words, if you plug 10 into your to your derivative, you're going to get 2,400 plus 2,400 is 4,800 minus 900, which is 3,700 or 3,900? 3,900.
Hey, Mr.
Yes.
Now, I did it a different way. I just put both equations into y, and then went to bars, y1, put in 10.
Yeah, you can do that.
Okay.
But look at the two. Why are they different? Somebody tell me why these two are different. I explained that to y'all a while ago.
The change of
No, go ahead. I'll discourage you as much as possible. I'll embarrass you if you're wrong.
One,
Yeah.
2 points and one's 1 point time.
Exactly.
So you're going, that's what I'm getting ready to say.
Okay, one is the slope or a approximate, and then the other is what? And what do you want to know if you're in business? You want to know exactly. Okay? And that's a little bit of what you're going to see as far as some of your homework problems with business orientation. What I'll do is I'm going to put some, and y'all can put your stuff up now. Now it's not rude after I tell you to put it up. If you look on your homework tonight, I'm not going to hurry. I'm going to try to work on it here in the next few minutes while I'm waiting on the video to download. I'm going to put some 2.1, 2.2, all the way up to 2.4. But 2.1, 2.2, and 2.3 is not that beefy. All right? It's going to be just a few problems. 2.4 is going to be a lot of problems. Okay? But they're going to be simple problems. They're not going to be hard problems. All right. Y'all have a good weekend. Oh, I'll see y'all tomorrow. I wish I could cancel class tomorrow, but I'd get called in.
Memorial Day is on Monday, so.
Yeah, Memorial Day. I don't think we have class, do we?
We do.
We do?
Yeah. Yeah, really? That's not our.
We don't if you cancel it though.
That is true.
Maybe if just nobody's. Wait a minute. Hold on a second. Hold on.
Email everybody.
Hold on.